So I want to go over the examples for general strategy for factoring. So these go with notes number 40. And these just happen to have more things to look for. And also to remind you, you have a series of questions to ask, and those questions will help you to remember to factor. So the number one question you are supposed to ask: is there a GCMF? So for every one of these, we're going to ask that question. This particular problem, there is one, 10x. So what I'm going to do is I'm going to go ahead and factor out 10x from each of these. So I get 10x, and then the remainder is going to be 10x cubed divided by 10x is x squared, minus 40x divided by 10x is 4. Then what we're supposed to be looking at is, do we have the difference of squares? Because I notice I have a binomial, and sure enough I do. So I can take the square root of x squared as x, and I can take the square root of 4 is 2. Let's make that a little nicer. So what we end up with is still we have the GCMF of 10x up in front, and then we're going to create two new binomials. And they have x's in front, 2's in back, one sum, one difference. And the only thing I need to check for is that difference to see if it's the difference of squares. X is not a perfect square, nor is 2, therefore I don't have any difference of squares left. So there's my answer. So if you remember the example we did in class, where I took an apple and I cut it in half, or I cut it in pieces. When I cut it into, did one cut, I ended up with 2 pieces. So every time you factor, you're going to get 2 parts. It could be a GCMF and a remaining polynomial. It could be 2 binomials. You never know. Okay? How about this one? T to the 4th minus 16. So always, always is the question, is there a GCMF? And in this one, there's none. So next thing I notice is I have 2 terms. So my question is it the difference of squares? So I can take the square root of t to the 4th and I get t squared, and I can take the square root of 16 and I get 4, which tells me it's the difference of squares. And remember, every time that you factor, you're going to get 2 pieces. So the 2 pieces here have t squareds in front, 4's in back, one with a sum, one with a difference. So what we need to continue to ask is, do we have the difference of squares? So I look at the binomial with a difference and see if it's the difference of squares. And sure enough, I can take the square root of t squared and get t, and I can take the square root of 4 and I get 2. So what that leaves me is my original binomial, which was the t squared plus 4. I cannot factor a sum of squares. But the second binomial, the t squared minus 4, factored into t's in front, 2's in back, one sum, one difference. The only one I need to check is the t minus 2 to see if it's the difference of squares. Neither t nor 2 are perfect squares, so I am done at that point. Okay. Next problem. We're going to have 2a cubed plus 10a squared plus a plus 5. So number one question is there a GCMF? And there's none. So now I look and I have 4 terms, which means I have factoring by grouping is my option. So let me rewrite the problem. And we're going to do it 2 by 2. So these have a 2a squared in common. And these have, if I can't find anything else, it's always going to be a 1, and in this case a positive 1. So what I get is 2a squared, and the remainder is going to be a plus 5, and then I'm going to factor out a positive 1, and the remainder is a plus 5. So what I'm looking for is having the same binomial, and it ends up being so in this problem. So the common binomial is the a plus 5, and the second binomial is formed by the coefficients 2a squared and plus 1. Now if you notice, all I have are sums, and so I cannot factor the sums. So that's that answer. And then we're going to get into a couple of tricky ones. So I have a squared minus the quantity 2x plus 5y, that quantity squared. And so this doesn't look like anything else that I've seen, because I've never seen binomials as part of another problem. So then I have to start asking myself, does it resemble something else that I have dealt with? And interestingly enough, I see I have a difference, and I see I have a perfect square, and I have a perfect square. And so what I have, believe it or not, is the difference of squares. So what I'm going to do is to take each of my perfect squares. Actually, let me change that color. And I'm going to take their square roots. So the square root of a squared is a, and the square root of the quantity 2x plus 5y squared is the quantity 2x plus 5y. So what I'm going to get when I factor the difference of squares, I'm going to use brackets because I'm going to have to use braces as well. I'm going to have the a in the front. Oops, let me get the brackets in there. So a's in front, the quantity 2x plus 5y in the back, and I have one sum and I have one difference. So at this point, the only thing I need to do is to get rid of the brackets, and so I'm just going to distribute to do that. And that gives me a, when I distribute a positive, nothing changes, so I get plus 2x plus 5y. But in the second one, when I distribute a negative, I get a minus 2x minus 5y. And there's no GCMFs. I cannot possibly factor these trinomials because I have 3 different variables. There's no even exponents, so that's going to be my answer. Okay. Now I'm going to do one more question that's related to number 4. And on number 5, we have x squared plus 10x plus 25 minus n squared. So I'm trying to figure out what on earth can I do on this problem. I mean, this doesn't look like, again, anything I've ever done. If I do a factoring by grouping, because there's no GCMF, so let's just establish that. If I try to do factoring by grouping, the first two have an x in common, and that would factor into x times the quantity x plus 10. The second have a 1 in common, which gives me 25 minus n squared in the parentheses. So basically, I don't get the magic to happen. So that says stop and look for something else. And the something else, those 3 guys, they form a trinomial square. So how a trinomial square works is I have the square root of x squared is x. Square root of 25 is 5. I know it's a trinomial square because when I multiply those square roots and double them, I do get the middle term. Okay. So what I do for my factoring is I pull out those two square roots and the sign of the second. So that gives me the quantity, and it's going to be squared, of the x plus the 5. Now I write out the rest of the problem. And what you should recognize is what we had in the last problem. Squared minus a squared. So this is a fancy way of doing a difference of squares again. So we're going to take the square root of the quantity squared is the quantity, x plus 5. And the square root of n squared is n. So the two binomials, actually I have to use brackets. They really aren't binomials, are they? I'm going to have the quantity, x plus 5 in the front. I'm going to have n's in the back. One sum, one difference. And again, I'm looking for what I have, and the number one thing I can't deal with is I cannot deal with two sets of grouping symbols. So I'm going to go ahead and simplify this by distributing out to get rid of the parentheses. And there's nothing in front of parentheses, so that just means in the front I get x plus 5 plus n. The other one I get x plus 5 minus n. No combining like terms, no ability to factor these trinomials because there's no squared variable, so I can't take any square roots. So that's the answer to that one. All right, one more for you. We've got 15 x cubed minus 20x plus 5x squared. And before I look for GCMF, there's something else that's a problem. And that something else is we need to put this in descending degree order. Which means the highest exponent is written first, then the next highest exponent, and then the smallest exponent. Now we're going to look for that GCMF, and we actually have one. They all have a 5 in common, and they all have an x in common. So my first job is to factor out the 5x. That leaves behind a 3x squared plus x minus 4. So I have three terms left behind, which is a trinomial, and the way to factor a trinomial, looking at what I have, looks like I'm going to have to play the game. It's not a trinomial square because 3 isn't a perfect square. So when I play the game, I put the product number on top. 3 times negative 4 is negative 12. The coefficient of the linear term is positive 1, and two factors that multiply, that give me negative 12, but add to give me positive 1 or positive 4 and negative 3. So what I do is rewrite the problem, and I'm going to create now a 4-term polynomial with two middle terms. So 3x squared, put the negative in the second spot, minus 3x plus 4x minus 4. And then what I'm going to try to do is factor by grouping. So the first two have a 3x in common, and the second two have a positive 4 in common. So I've got still the GCMF out in front. Remember when I was cutting up those apples today, nothing disappeared, did it? Oops, sorry. I'm going to have to use brackets again. So when I pull out the 3x from the first, it leaves behind an x minus 1. And when I pull out a positive 4, it leaves behind an x minus 1. So there's my miracle, where I have the common binomial of x minus 1. So I still have the GCMF, and then I end up with two binomials. The first one contains the common binomial factor of x minus 1, and the second one contains the coefficients that form their own binomial. Now, x minus 1 is the only possibility for the difference of squares, but it isn't because x isn't a perfect square. So that's as far as I can go, and there's your answer. All right, good luck with these.